Good day. Today's demo is going for chapter 7. We're doing Ethernet switching. So first thing we want to do, so we're layer 2. So we want to convert these subnet masks. So if you look on the topology, you have a 10.10.10.1 with a /28. So to convert that, the subnet mask currently is 255.255.255. So you put in the first octet, there's 8 ones. Second octet, there's 8 ones, so that's 16. Third octet, another 8. So now you're 24, and we need to get to 28. 25, 26, 27, 28. And to calculate in binary, 1111 is add 128, 64, 32, 16, and that equals 240. So then we can go here and add our subnet mask here so I won't forget. So I'm going to add that to the documentation on the topology. This would be logical topology at this point and physical. Okay. Now let's go to the 172.16.11 with a 27. Once again, put down the subnet mask of 24, and then we need 3 ones. Then we add 128, 64, 32. That will be 224. Then the last IP is 192.168.11, 26. So once again, first octet, second octet, third octet are full of ones. Now we need to get to 26. We got to go 2 more. You add 128 and 64, you get 192. So go back so I won't forget. And then over here, 224. So you want to double check your IPs on your interfaces. So if we look at FA80, it's a 192.168.11. And then the fast Ethernet 00 is 10.10.10.1. So the switch here is going to memorize any MAC address that comes in. So to enable to see that, we get into enable mode and show MAC address table. And it sees something in FA81. And that must be the router. Since the router's up and communicating, remember when that router comes up, it goes an amber light, and that's when they record the MAC address. So there is your layer 2 MAC address, but it doesn't know any other MAC addresses because we have not generated any traffic. And that's one thing about Ethernet, it can lay undetected for long periods of time if there's no activity generated by that device. So we can have 2 types of switching. We have store and forward. Store and forward means that it reads the entire frame, which is 1500 plus bytes, and then determine where's to send it. Now the easier or the faster method is a cut through. And so the fast forward method will read only up to the destination MAC address. So it's going to read very quickly, but no error detection. And then there's a fragment free version. So if you have errors using fast forward, you want to switch it, or it should switch automatically to the fragment free, and then it will read the first 64 bytes to determine if there's any errors and where to send it. Then how does the devices get to share the memory? So there's port-based memory, which means every port gets equal memory. So every port gets equal memory. In a shared memory, all ports share the memory. So I would say shared memory was good for devices that use the same amount of bandwidth. Port-based memory, port-based would be for all those devices that use the same amount. Shared memory may be for maybe there's a server with a bunch of end devices. So that's something we'll deal with later in some advanced switching. So what we're going to do now is we already checked the switch MAC address table, and that's actually stored in the CAM memory, CAM, content address memory. So you'll need to remember that. So there's nothing in the switch except for F801. So let's go to PC0. and check the ARP table. So that'll be ARP-A. So there's no entries. So let's generate traffic. So let's go ahead and ping our gateway. That'd be 10.10.10.1. And we get a reply right away. And then if we do again, show the ARP, we see that we have a IP address layer 3 and it's mapped MAP to the physical address. So that's a binding. Now if we go to the switch, and we do it once again, show MAC address table, we see we have an entry on FA91, which means PC 0. So let's repeat. Let's ping the server. Get my window out of the way. So let's ping the server .10. So go back to command prompt, arrow up twice, change it to 10. And then how fast does it happen over here? As soon as that first traffic announces, it records. And so once again, we're going to check the ARP table. And we see now the 10 is now have a mapped address with the layer 3 and layer 2. Let's go ahead and ping .12. I think in class last night I was pinging the wrong IP and it wasn't available. .11. Once again, go to the switch, do your MAC address table. So each time we ping, so I'll ping .13 next. Each time we ping, the switch then will add another entry. So every time a device communicates. Now, what we're going to do next is ping outside. So let's just go ahead and ping this end device over here, this 172.16.130. And remember, we're going to have some ARPs, so we're going to have some timeouts. It'll time out in a LAN, it'll time out in a WAN, and then another ARP. So it should have 3 ARPs. So we'll try to watch that in simulation. So let's ping 172.16.1.30. So we want to be able to see this in the packet tracer so we can determine some things in the end. Just speed it up a little bit and then enter. So let it play. Notice that we didn't need an ARP. All right, let's go. I'm sorry. Unless routing's enabled, we're never going to reach that. So let's just ping the 192.168.1.1. Let's see if we can ping that. 192.168.1.1. Okay, that worked. So let's go to simulation. Let's ping .2. Now, let's take a look. Here's your LAN. So here's your LAN below, and here's your WAN. So the LAN's this interface down, and then the WAN goes here. So are we going to get an ARP going to the side of the router? .2. So ICMP, remember, only goes to layer 3. So there's your layer 3 address, layer 2. Goes up to the router. There's your ARP. So remember, and it leaves the router, it needs to find out the MAC address. So there's your layer 2 broadcast. And layer 3 knows the IP because they're connected through layer 3 routing. So we'll let that play out. Now we should go down. And there's another ARP. So that was successful. So you can see that it's not pinging because I don't think we have routing enabled. So you can get to your local router, but not outside. So to get that to work real quick, I'll throw in a real quick route that we're going to use for our final exam. Config T, Control-Shift-6 when you have a typo. Then it's IP routes. We've been doing this in class. That turns on routing, and it says send all traffic out either local interface or next hop address, which would be the next IP. I'll put FA 8/0. So let's go here now and see if it pings. So once again, we're trying to ping to the next router, which would be considered the WAN, and back. And it didn't work last time because of routing. Through the switch, up to the router, this time across. Okay. So another failure. Because at this point, router 1 does not know how to send information back. So to fix that again real quick, and this is beyond our course, but if you want the final exam to work 100%, so config T, IP routes, 0.0.0.0, 0.0.0.0.0. So we call that quad zeros. Oh, interface. So it's got to go out FA 1/0, 0. All right, once again, let's see if we can get this to ping. Once again, up to the switch, records the MAC address. Now it should go across the WAN link. There's your ARP. That's what we were looking for. So there's our FFF. So now it's going to ARP back. We should see at this point, it removes the broadcast destination address and puts on the destination address of the end device. And that should have been successful. Reply. So now let's take a look. What's the MAC address of FA00? So follow that. It ends with C1AE. So C1AE is the last 4 hex sets. So let's see if the switch recorded that in the MAC address table. It is not here. So we know that the MAC addresses are only used for local significance. So can we clear MAC address table? Clear, question mark. Oh, there it is, MAC address table. Then we can show MAC address table. So show MAC address table, nothing in there. Let's go back to our host. Let's see the ARP table. ARP-A. Can we clear? ARP-D. ARP. Oh, well, ARP-D worked that time. So now if we do arrow up to ARP, there's no entry. So to remove them, so this could be used in a reverse tool of hacking with spoofing MAC addresses. And so we're going to use this technology and also find ways to reverse it and attack other devices and shut down layer 2. So this concludes the video on Chapter 7, Ethernet switching.